On a site founded on firsts, it's not surprising that the West Valley Demonstration Project has become the first site in U.S. history to place high-level waste into long-term outdoor storage. In 1966, West Valley became the first site in the country to commercially recycle used reactor fuel. Over the next 6 years, site workers processed 640 metric tons of spent nuclear fuel.
West Valley was the only commercial nuclear fuel reprocessing plant in the United States to ever operate.
They took commercial fuel and they basically tore it down into the different chemical components to reprocess it, just kind of like you're recycling.
In the course of the reprocessing of the reactor fuel, they generated approximately 600,000 gallons of high-level nuclear waste.
By 2002, West Valley workers had solidified the liquid high-level waste, converting it into stable glass logs through a process known as vitrification.
The project was a very big success between about 1995 and 2002. 275 canisters of vitrified waste were created from the 600,000 gallons.
And now the glass is still left in the middle of the building in these storage containers. They look like glorified milk cans.
The objective of our contract right now is to perform D&D of the site and to demolish the main plant building.
To accomplish this, the canisters must be removed from the building. DOE selected to pack the canisters in concrete casks, a technology adapted from the commercial nuclear industry.
They are passive systems that do not require any care or maintenance for a long period of time. They're licensed for 50 years right now.
The stainless steel canisters containing vitrified waste will first be loaded into a high-level waste overpack, which will hold 5 canisters. The overpack will then be placed into a steel-lined, reinforced concrete storage cask.
It's got a liner, and outside that liner is a bunch of rebar, very dense, vertical, horizontal, all the way around. And then what they do, they fill up that cavity where the rebar is with concrete. So there's a form on the outside that holds the concrete in between the inner liner and that form. And then when they're all said and done, they weigh 87.5 tons.
When a final repository for high-level waste is established, the 5-canister bundle inside the stainless steel overpack meets all state and federal regulations for off-site shipment. On-site facilities and infrastructure required upgrades to accommodate the process.
In the facility, we did have to do some modifications, but we wanted to minimize our improvements to the facility because we are demolishing it.
We had to improve the floor loading capabilities of the equipment decontamination room so that it could support the weight of the cask and the machine that was on it. We did that by using grout injection into the soil to improve the stability of the soil and increase its load capacity. We had to upgrade the haul road between the loading facility and the pad. As you can imagine, an 87.5 ton cask that's lifted by a piece of equipment that weighs about 50 tons itself, you need a lot of structural stability in your road. We also had to construct the pad for the interim storage of the casks.
The 16,000 square foot storage pad with 3-foot foundation required 133 tons of reinforced steel and 1,800 cubic yards of concrete.
We had 100 trucks a day come in as we were placing the concrete. It was quite an undertaking.
Due to the high levels of radiation in the canister storage location, all work would be performed remotely.
The radiation levels inside the cell prohibit any type of manned entry, so everything we do in that cell is done remotely.
A low-profile rail cart was constructed to allow movement between high-rad areas and load-in, load-out facilities. Highly skilled remote operators load 5 canisters into a specially designed overpack. Again, remotely operated cranes move the 5-pack into a cask, aided by a multitude of cameras to guide the process.
You can't go into CPC. There's no way. The red levers are way too high. You can't go in there. It's a pretty simple operation of the grapple grabbing a hold of it. It's the camera angles. You get the camera angles right, set it down on there. There's a certain sequence you have to go through to lock it on and unlock it. But once you get centered up on it, drop it down on it, bring it up, and pick them up.
Radiation levels for a single stainless steel canister can range from 2.5 million millirem to about 7 million millirem. Once placed into the storage cask, the radiation levels are reduced to 1 millirem. For perspective, a typical chest X-ray produces about 10 millirem of radiation. While there's reduced radioactivity on the circumference of the cask, significant radiation is emitting from the top of the cask. That is remedied by the placement of an overpack lid, lid shield, and lifting bail, again by remote operations. The cask is now moved into the welding station via an air pallet. The lid bail is removed to enable welding of the overpack lid to the stainless steel overpack. Operators control the robotic welding arm by computer control panel.
It's automated welding, but it's basically a remote because of the high radiation fields that we're dealing with. We only have a small time to react. I mean, you only got an inch of view on the screen of the camera what's coming up. So you got to realize if the weld is, if the joint is wider or narrower, you kind of pass that on. Once you start it, you can't stop. You got that whole process you're doing. It's one weld at a time. It's a long weld. It's about an hour a weld.
After multiple passes, quality control personnel verify the weld integrity.
It's sealing everything up, keeping contamination in, and it's what they're going to use to eventually. It's got to be strong enough to pick the whole container out of that cask.
RAD technicians survey the weld to ensure readings are within safety parameters.
That's mainly our job as RAD to actually protect us, the personnel, and the environment from release of any sort.
After the lifting lugs are attached, the cask is ready for the quarter-mile journey to the storage pad.
From load-in down to the high-level waste pad takes us approximately 30 minutes of travel time.
The vertical cask transporter is a mobile gantry crane used for the heavy load. The mobile crane is pulled by a tugger, similar to those used to tow airplanes.
The main thing we did to that was put some extended mirrors, similar to what they use for moving mobile homes, so we could see. And then we hitched that to the VCT, which basically only has a motor that drives the hydraulics. So it's like a big hay wagon.
After 4 years of preparation, the excitement of success is evident.
It's been a long time. It's kind of exciting to get that first one out. I mean, everybody's worked hard.
It's stressful, but it is kind of cool too. We want to get the job done right and correctly, and it's totally new for me. And like I said, I'm used to hands-on. Now going back to hitting a touch screen, that's totally different. The kids will do great with this. To them, it's like a video game.
In total, West Valley crews will transfer 56 casks to the interim storage pad. The team is scheduled to achieve its next first by 2018, becoming the first site in the DOE complex to relocate its entire high-level waste inventory to long-term passive storage.